Sometimes you're right. They're good. Okay. Anyway, sting is probably why. Kiddos, the last thing we saw yesterday was this really cool formula, but remember it's a really cool shortcut formula that only works for the easy ones. But these two are easy ones. So just really quickly, did you guys figure out how to use the formula last night? Let's see. So how could we quickly find this guy's inverse? If you want to put it in your notes, cool. If you want to just listen, cool. We're just seeing if we know how to use the formula. The formula says, right, 1 over main minus opposite. What does that mean? Oh, hey, this is a determinant. It's a formula for, well, somebody that I told you was important for matrices and really 2 by 2s. Anyway, if I multiply, I get a 6, and if I multiply, I get a 2, and I subtract, and I get a 1/4 in front. Yeah? Main minus opposite. Determinant. But don't you also have to flip the main in this formula? So the 2 goes up, the 3 goes down, opposite the opposite, so a positive 2 and a positive 1. So then we go ahead and have that matrix. Wait a minute, so does the inverse exist on letter A? Yes. Why? Because there's an answer. Oh. And the inverse is 1/2, 1/4, 1/2, 3/4. Dun 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 dun. How about this guy? 1 over 6 minus. Uh-oh. There is no determinant because is that going to exist? One over 0 is undefined, so we say no inverse. And what's that snazzy vocab term from yesterday that described any matrix, square or non-square, whose inverse does not exist? If the inverse does not exist, it's a lone wolf. Singular. Well, because a lot of us, I mean, don't our brains naturally go to the negative? We're like, oh, it must be non-singular because it's non-something. No. Singular means it's on. There is no inverse to go along with it. So non-singular means, oh, it has an inverse. Look, it has a friend that will be its own undoing. Oh, that's not good. Anyway, so noise. Not noise, a little scary. There technically is, since we're here and since we just did a couple inverses, it's probably a bad idea to plug that in, although maybe it's good to see what your calculator would do. Did you guys hear me say just a second ago, grab out your calculators because they can do inverses? Can you guys go ahead and plug in matrix A and see if you can get your calculators to give you 1/2, 1/4, 1/2, 3/4? Go ahead and plug in matrix A. You guys know what to do, right? You're going to the matrix menu, going to the edit menu, editing A. Throwing in the matrix. And then you're looking around for inverse. There's that matrix math menu. That has a lot of stuff. Hey, if you look at matrix math, is there something called determinant? Ooh, well that's inverse. Anything inverse? Anything inverse? What'd you guys find in the matrix math menu? Anything that with the word inverse? No. Okay. Do you remember how for degrees, minutes, seconds? Ooh, that's been a while. For degrees, minutes, seconds. Do you remember how the angle menu only had degrees and minutes but didn't have seconds? Do you remember why? We could still find seconds, but it wasn't in that menu. But why? How do you find seconds on your calculator? Let's take a second and try to... Alpha plus, was there somewhere else on the calculator where the double quote was already there? Yes, so the programmer said instead of making a new function in the angle menu or a new option in the angle menu, I'm just going to say, hey, if they use a double quote in this context, it means the following. Could the double quote also just be a character that you put in? Yeah. But in context, the double quote, it was already somewhere on the calculator. If you put it in degree mode with a degree and a minute and a second, it knows what to do. So what does that mean about inverse? It's somewhere else already on your calculator. It's somewhere else already on your calculator. Who's found it? Kyle just showed me his calculator. And where did you find it? Aiden, where'd you find it? Right under the math button. But you use second? You don't use second. Do you see the little inverse notation? Right under the math button? Inverse, a little -1. Now hold on. Can you use the little -1 with matrix A and see if it works? The answer should be yes. If you look right underneath the math button, there's a little -1. Now hold on. Doesn't -1 mean more than one thing in math? The same way the double quote could just be an alpha character, but it means seconds in this context. What else could -1 mean? Next to a matrix, it's going to be inverse. But what is next to it? Oh, so if I were to try this, if I were to do this with like square root of x, that's going to be x squared, right? Wait a minute, doesn't it mean inverse with this? But this one means what? Reciprocal. So what's it going to mean when I'm doing it to a function? Now, you guys might be thinking a function like in y equals. You could theoretically plug something in like a 25. What's the inverse of a square root? A square. But hold on. What will this mean in every context except for this? Just the reciprocal. Does that make sense? Yeah, you're welcome. The little inverse button is also the reciprocal button. But guys, even though -1 is used in many different ways in math, or at least 2 very important different ways, that doesn't mean that these are the same thing, right? What's the right word for this? It's not inverse. You guys have already said it. Good. So could one thing in your calculator do 2 different operations? Yes. It's all about, what's the word that I've said a few times? Context. The programmers could use the exact same button for different purposes depending on where it shows up. So if you put it next to a matrix, yeah, you'll get the inverse. If you put it next to a number, yeah, you'll get the reciprocal. Now pause. Did you guys already try it with B just to see what your calculator would do? A, to make sure that we were right, and B, to make sure we were right, and B, to see what the error message is. What's the error message? So you're putting in a new matrix, matrix B. According to our math, the inverse should not exist. If we were to do this with a system of equations with A, B, C, and D, we would get some sort of false statement to let us know that there is no solution. If we were to try to row reduce echelon form by double matrices, all things we're going to be grading in 1 second, we would not be able to totally. What's the calculator say? Singular. Oh my goodness, it knows our vocab terms. Singular matrix, no inverse exists. Does that make sense? Go team. All right. Odds. Before we go to the evens and before we grade the evens, were there any odds that you guys got stuck? Oh, I had a homework help we didn't get to look at. But wait. Do you think you were using your calculator? Yeah. Could you have made some fractions if you really, really wanted to? Yeah, but if you were using your calculator, just use the decimals, right? Wait, but how are you supposed to solve equations? Because I'm thinking maybe some of our questions revolve around this. How do you use an inverse matrix to solve an equation? Did you guys take to heart what I said yesterday when I talked about if you have multiplication of matrices, how to undo? What was I talking about? Can't I rewrite this as a multiplication of matrices? This times x and that times y, and this times x and that times y. How do I move one side to the other? Divide. No, what did we see yesterday? You can't divide matrices. You can divide scalars, but not matrices. So what's the way to undo? A times variables equals, I don't know, C? I need A inverse. Because if I do A, what do I get? The identity. Identity times the variables. Yes. Get X, Y. Hold on. What's illegal? What did I do that was wrong? What I did to one side, what should I have done? I should have done to the other. So all you need to do in your calculator was, hey, who's A inverse? And let me multiply him by, I guess you guys probably would have called him B, right? Okay, let's see how homework went. Now, what we do. I bet we might need to use that at some point in time. We have the evens to grade, but first of all, the odds. Odds, you've already graded. You've already looked at Calc Chat. What do we got? 71. Anything before 71? Yeah. Odd for right now, because we haven't graded the evens. All right, 71, let's peek at that, and then we have no other odds, and we'll go grade the evens and see how you're doing on those. So number 70, oh, sorry, nope. Okay. Hey, what does letter C's directions look a lot like? Solve an equation using an inverse. Check it. What does C say? Solve your system of equations using an inverse. Find the number of flowers of each type that the florist can use to create the 10 centerpieces. So I'm assuming, Adam, you've already made a matrix, true? And you wrote some sort of system of linear equations before that. So here's my question. What was the coefficient, or what is the coefficient matrix? How many unknowns do you have? And what's over here in the equal spots? Do you know what I'm talking about? So if you took out all your x's, y's, and z's, what was left over here?
1, 1, 1, and then 2, 2, negative 1, 2.5, 4, 2.
So you have 3 unknowns, x, y, z? Yeah. Are there 3 different types of flowers?
Yeah.
Got it. And then what was our overall, what's 1x plus 1y plus 1z? What did it equal?
120.
Cool. What did 2x plus 2y minus 1z equal? And what did 2.5x plus 4y plus 2z equal?
300.
So guys, looking at the example I just did, how would you answer Adam's question about how to solve this matrix equation using an inverse? Whose inverse do we want to undo? Who do we want to pull away from the variables? The coefficient matrix. So I would throw this guy in. Why is it red when? Oh, because it's in here. Sorry. I would throw letter A into your matrix and B. So you would need a 3 by 3 and then a 3 by 1, right? Then I would go ahead and just say, sweet, my variables are going to equal A inverse. And we learned how to do that on our calculator times B. Go to your home screen. After you've put in A and put in B, A inverse times B, we're done.
Because in CalcChat, like it asks for 10 centerpieces, but on CalcChat it's like 4 pieces. That's where I got confused.
Oh, that is confusing. Yeah, no, stick with the 10. Every now and then there's typos. Yeah. Yeah. Because we didn't talk about inverses of 3 by 3s yesterday, at least not too much, right? Okay. Yeah, I apologize for the typo on CalcChat. Let's go grade our evens. Kyle. You got it? There you go. Okay, evens. Number 6 should have been negative 10. Number 16, the determinant should have been 34. Oh, no, I'm sorry. Thank you. That's rough. Ugh. Number 10, the answer was yes. Why? Because they both got the identity. Number 10, the answer was yes, because they both got the identity. Do you see how they pulled out the 1/4 to make their life easier? Number 18, it was doubly augmenting and row reducing. Since there was an identity, since there is an identity, guess what? The inverse exists. Go team. Since there was an identity, since there is an identity, this is not a singular matrix. Because the identity came about, we know this is the inverse, and we're done. If this was impossible to get, then we would have to say no inverse, non-singular. Number 20, same thing. Oh, hey, guys, if you have a 3 by 3, you can find an inverse. Just doubly augment with an identity matrix of the right size, row reduce. Were they able to get the identity matrix? Yes. So who is this guy? The inverse, of course. To row reduce, you undo everything. And when you undo everything, if you truly can get to the identity matrix, the inverse exists, and there he is. Number 40. I think they're having you use the formula for the inverse. Because right? Some of you might have been like, but the numbers were gross. Yeah, but it still works. Yeah, but it still works. You could have tried to pull out a 1/3, no, a 1/9, a 1/36. You could have tried to pull out a 1/36 and make it nicer. Or you could have just gone for it. Going for it, you end up with a determinant of negative 143 over 36. So 1 over that ends up flipping it. So remember the formula goes 1 over this guy, hence why it flipped. Flip the main opposite signs of the opposite diagonal, and then you bring it all in. Whoosh, 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 whoosh. Done. Number 50 was a lot nicer, even though the numbers were big. Quick multiplication gets us our determinant of 1 over 72. And then we end up with the inverse matrix, and they're saying multiply that inverse matrix by, it was just what we were talking about. So some of you might have gotten confused, but once you get or see what you need to undo, find his inverse and multiply that on the other side to solve. That's what's going on. The final solution is 1/2, 1/3. And then we're done. Evens, do we need any clarification on any? Evens, do we need any clarification? 20? Thanks, Gavin. Does it make sense, the goal of 20, how we're doubly augmenting and row reducing? All right, shush on the phone. Can you turn off the sound, Jason? Thank you, thank you. Thanks for letting me know. So the idea is to row reduce it. Let me just kind of, can I zoom in on the steps? I'm going to see if I agree with their steps, because if for any reason I don't agree on the steps, like if I would have done it differently. But otherwise, we can just kind of check your work, Gavin, and see where it went wrong. Because row reducing, we're reviewing. Yeah, it's saying that from our notes yesterday, we said there were 3 different ways to find an inverse. One way is taking the matrix itself when it's a 2 by 2. Otherwise, let's see if it's a 3 by 3. But taking the whatever matrix it is itself, 1, 2, 3, and 4, and by A, C, D. The second way that we learn, because we're like, well, this one's great if it's a 2 by 2, but if it's a 3 by 3, well, that's going to stink, because there's going to be 3 different systems of 3 equations. It's a mess. Actually, which we did a 2 by 2, but you can also do it with a 3 by 3. And the goal is do all of your operations to make this side the identity. And when you make this side the identity, since you have to do the operations all the way across, this one you can get here becomes the inverse. And there was the formula that we just looked at, which only for 2 by 2. So from yesterday, this was the only way, the best way to solve for the inverse of a 3 by 3, was taking a 3 by 3, augmenting it with an identity matrix of the same side. And what we're doing is our REF from section 8.1. We already had the 1, let's get our zeros, and they did. But you had to do those operations all the way across. Then the second column, let's have our 1. Oh, it's already there. Let's get our zeros, and they do. Doing those operations all the way across. Then let's go to the third column, get our 1. Get our zeros, which they do, all the way across. And with all of that work going all the way across at the very end, once they ended our REF procedures to get the identity matrix, this was the inverse done. Does that kind of make sense? Okay. Good question. with that, kiddos, let's go back and say, okay, what's section 8.4 going to tell us? Nice thing is, if you guys notice, the formula on page 1 of section 8.4, the formula on page 1 of section 8.4 is one that we already started using yesterday. One we already started using yesterday. Now, do you think this is all that section 8.4 is about? No. These are just the easy ones. I'm sorry, they're just the 2x2s. These are just the easy ones. These are just the 2x2s. So we already saw the easy ones. We already saw the 2x2s. We see how determinants are used. I just said something like, hey, it's kind of like a dot product in that for matrices, determinants are super useful and can show up in lots of different ways. We saw how to do a 2x2 last section because we were using it. We saw how to do a 2x2 last section because we were using it. And so we're starting there and being like, yeah, there's a cool formula for a 2x2, but the dilemma is just like with inverses. Just like with inverses, 2x2s are easier than the 3x3s and beyond. So basically, let's figure out how to do determinants of bigger matrices before we, in future sections, learn how to use them. And not all the different uses, but at least some. Okay, there are some notations for determinants, first of all, before we go play around with the 2x2s that are really easy and be like, yay, this is fun. Couple things. Determinant could be a DET of, when you guys get the whole name of matrices, don't they put them in brackets? Is that right? Okay. So you could actually write it DET of A. That's one way. You could write it DET of A. You could write it absolute value of A. Magnitude. Well, because absolute value of a complex number, remember, was its magnitude, like the double lines of vectors. I wouldn't exactly say it's the magnitude of the matrix. That's not quite applicable, but we do know that absolute values can mean different things in different contexts. Stink, lots to do with context. So today, absolute value for or around a matrix will be a determinant also. And then technically what you also could do is you could put those absolute values around the entire matrix, which is confusing to some degree. I get that. It's confusing because the brackets versus the absolute values, they look so similar. But if you have a matrix in absolute values, it also means determinant. So all of these point back to that. Which, easy formula, yeah, with 2x2s. Easy formulas with 2x2s. Let's go find the determinant of A. Let's go find the determinant of B. Let's go find the determinant of C. And I'm using all my notations. Okay, what's the determinant of A? 3, which Jason was totally right, is a 7. You guys agree? Main, remember, we multiply. Main 4 minus -3. How about B? Zero minus, wouldn't that be like a 2 over 1? And the 2's cancel when you multiply? Yeah, good. So 0 minus 3, which would be -3. Question. Which of these matrices is singular? Only B? Second guess and then be wrong when you write. Anyway, B is the only singular one. Why? I can always flip the main and opposite the opposite. What makes the inverse not exist is the 1 over 0. which this one would not be, that one would be, and this one would not be. This might have some weird numbers, that might have some weird numbers, but that one's going to be just fine. Cool? Okay. But what about others? Even though I said 2 by 2s are really easy, you guys are going to like 1 by 1 even more. But anything higher, you're going to be a little sad. 2 by 2s are easy. It's opposite. One year we said main minus opposite. I don't know why. I think we just said main opposite. We were being lazy. But main minus opposite works for 2 by 2s. 1 by 1s. Let's do main minus... Wait. Well, there's only one term, so guess what the determinant is? Yep, it's that easy. But that's not the formula. Well, yeah. Only for 2 by 2s. Oh. And there's a variation that works for 3 by 3s. But the variation only works for 3 by 3s, not 4 by 4s, 5 by 5s, and 6 by 6s, sadly. My mind would actually love it if it would work for bigger ones, but it doesn't. So I'm not going to show you that way first. I don't think I am anyway. Instead, I'm going to show you what works for any square matrix, not just 3 by 3s. There is a formula way with the 3 by 3, but it breaks down. It does not work with 4 by 4s. It's literally a trick. And so I'll show you the trick before the end of the day, hopefully. But that's not what I need to focus on. What I need to focus on is everything higher. What do we do? Everything higher. What do we do? Kyle, I'm coming to you. Let me zoom in on here so people can start writing. Cool? What's that?
So you know how like when you're trying to that you like convert like A and CD? Like if you could possibly do like 3 by 3 fourths. I guess if you get
Oh, you're thinking inverse.
yeah, like what if you get to like a 6 by 6? You couldn't convert numbers to letters because you'd be over it.
Well, get to that, probably they'd be using Greek letters. They'd be using scripts. A1, A2, A3, A4. Yeah, that's a good point. If A is a square matrix, why? Determinants only exist if square matrices. Oh. Determinants are only of square matrices. If A is a square matrix of order 2 by 2 or greater, the one way that works for every single size matrix is the following formula. Do you guys see the little absolute value notation? So when it says absolute value with a matrix, what does that technically mean? Determinant. The determinant of A is the sum of the entries in any row or column. Any row or column. Sounds like we get to choose. Then the determinant of A is the sum of the entries in any row or column. Oh, hey, look, they're using row 1, A11, A12, A1, however big it is. Because remember, it's of any size. It could be an n by n, so I don't know. Maybe it's a 10 by 10. I have to go all the way to A sub 110. They use the first row, but it could have been any row or any column multiplied by their cofactors. Whoa. There should be something in your brain right now that's saying ding, 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 ding. I don't know this word. Expanding along the first row would yield. Applying this definition to finding a determinant is called expanding by cofactors. This formula and how it works and how it finds a determinant is the process called expanding by cofactors. And so that should be begging the question in your mind, if all we need is this formula, the only piece we're missing, we know how to add, hopefully. We know how to steal all the guys from any one row or any one column and write them separate. But what we don't know is, who on earth is this guy? Who's C11? Who's C12? Who's all the different C's? So now that you have a formula, and now that it's a formula that can find us any determinant of any size, which is the goal of this section, we have to say, well, who on earth is a cofactor? Who on earth is a cofactor? All right, other determinants. What works every time? 3 by 3s are higher, a bit more complicated. What did I mean? Well, this is how this formula gets used. If you guys notice, there is no like adding or subtracting right now, like plugging in, but this does end in a who or what or how to find C, which is what we're missing. So here's the dealio. To find C, we have to talk about M, because C is defined by M. Oh, well, that's hard. Okay, so to find the C, that formula, we have to talk about M, minors. Hey, what most of you are. Minors. Minors. Enjoy it while it lasts. The bills, the responsibilities, the adulting is coming. Minors, determinant of the matrix resulting from, what? The determinant? A minor helps us find the cofactor, which helps us find the determinant. A minor is a determinant? How does that make sense? Yeah. A minor is a determinant of the matrix resulting from, and here's the key, ignoring the nth row and the nth column, so it breaks it down. The minor says, I'm not looking at the whole thing, I'm just looking at a piece. And the piece that I'm looking at is what's left in a whole column. Who's left and who's, see the little absolute value bars? So M11, M11, M of the first row, first column says ignore the first row, ignore the first column. Who's left? M is that determinant. It's not considering the whole thing, it's just considering the piece. And the cofactor says take that minor and then assign to him either a positive or a negative based on the pattern below. Uh-oh. Zoom in on the pattern below. The cofactor basically says take a minor, take the specific minor of ignoring whatever row, whatever column is denoted. Take whoever's left, find his determinant, and make it a positive or a negative. I shouldn't say make it. I should say multiply it by a positive or a negative based on the pattern below. Based on the pattern below. The pattern below is actually pretty easy because the pattern below, all it says is, you know what? All you got to do is stagger, alternate the signs. If it's M11, aka ignoring this guy's row, this guy's column, use the positive or multiply by a positive. If it's this guy, ignoring his row, his column, use a negative. If it's this guy, ignoring this row, this column, use a positive. We stagger, or I should say we alternate the signs of the minors. Now this is going to be kind of hard unless you see an example, and so I'm really trying to end today with you guys. Ooh. Seeing me playing with one of these. Now, I'm going to start off super easy, just so that we get the idea. Because if this is already a 2 by 2, and if minors break down 3 by 3s to be 2 by 2s, broken down to 1s, they're easy. So minor 1-1 would say ignore coming from positive, negative, negative, positive. What spot? 1-1? Positive. So I'm going to do a positive times a negative 4 for my cofactor, so the cofactor is just negative 4. However, what happens if I go M12? I'm now ignoring what row, what column. Ignoring his row, his column, who's left? And the determinant of 3 is just 3, but the cofactor says consider the sign. What's the sign? So what's a negative times a 3? They're both negative? No. One stayed the same and one flipped. So really what this little chart is saying is keep it the same or flip the sign. Keep it the same or flip the sign. It doesn't mean the answers are going to alternate, but keep it the same or flip the sign is what's going to change. How about 2-1? What row, what column are we in now? Second row, first column. Ignore the second row and the first column. What's left? 10. Determinant's 10. That's why we're starting easy, because we can see the determinant of a 1 by 1 super fast. Cofactor says, what spot am I in? The opposite spot, which means flip the sign. And M21, no, sorry, M22 says, okay, finish this off. What's my last one? 0. Go keep it the same. Well, I guess it doesn't really matter. It's 0 either way. So wait, how does this apply to anything? Like, we were just kind of practicing who are C's and what's this little plus minus thing talking about, and what's the M breaking it down and ignoring stuff talking about. Didn't we say there's a way to find determinants of any matrix of any size? Any square matrix of any size? What was the formula that you guys just wrote down a second ago? Wasn't it steal any column and multiply the entries of that row or column by the cofactors? What do you guys want to steal? Do you want to steal the first row, second row, first column, or second column? Doesn't matter. You just got to pick one. First row, second row, first column, second column. Pick one. First column. So, column, guess what? The determinant of A is equal to choosing the first column as, or for my formula. I'm going to use A11 times C. To use both entries in this column to do what Kyle asked, times C21. 1 plus 21, 3 times C21, negative 10. It's the same thing as take the 0 that you used to find C11 using the right sign. Use this and multiply by what's left. Use this and multiply by what's left. And then you end up with a final determinant of 0 minus, which, guys, isn't this the same thing as, if we did it right, main minus opposite? Yeah. But it was so much harder. Yeah, it was starting you off easy. We're not going to use this for 2 by 2s. We're going to use it for... Because 2 by 2s, if you break it down to 1 by 1, why don't you just do main minus opposite? But it's 3 by 3, we're like, But if we break it down, can we do main minus opposite of each of the cofactors? Yeah. We don't know what to do with the whole thing, but we can do 2 by 2s. We can do 2 by 2s. We can do 2 by 2s. And so this process says, if you need to jump to the end, banding by cofactors, do you guys see that I'm choosing the first row? Do you see that I'm choosing the first row? Okay. I'm going to find the determinant of A. I could have chosen any column. First row. My cofactors says when you go to find the cofactor and you circle, you ignore, and you ignore. You multiply it by the number of the entry like we did down here. However, I also need to think about with my signs. Whether to say the same or the opposite. So if I'm choosing row 1, I'm going to steal the 0 with the determinant of its cofactor. Sorry, with the minor, the determinant of what's left. Say, I need you to say the same. But then I need to go ahead and say, but now it's time for me to get the other one. Or the I have the 2 times his minor, which would be the determinant of what's left. And I'm going to steal the next sign, which is a negative or opposite. Then, well, wait. How would I finish this off? I have the 0. I have the 2. What do I need? I need to finish off my row. I'm going to cross, cross, and I'm going to multiply by the minor, the determinant of what sign am I going to steal? Use. Same, please. And what am I going to do? Add them all up. How do you add them all up? Well, there's still something to be done, isn't there? What work still needs to be done, guys? Absolute values around matrices mean what? Determinant. So I'm going to end up saying, okay, the determinant of A, if I add all this up, is going to be positive times 0 is 0 times, what's the main minus the opposite? What's negative 1 minus 0? Well, we'll get to it in a second. Minus 2 times main minus opposite, 3 minus 8. plus 1 times 0 minus negative 4 equals 0 times anything. 0. 3 minus 8 is negative 5 times negative 2 is positive 10. 1 times 0 minus negative 4 positive. Guess what my determinant is? How could you check and see if I was right? Didn't we just say a second ago you saw or you inverses? Could you throw in matrix A, take DET, the determinant of, and it would match? That would. Wait a minute. But you used row 1. Row 2. Or row 3. Or column. Any one row or any one column. That's what all of them will end up becoming. You did it right, 14. Kim. Okay. So what is this whole process called? Cofactors. Is there any other way to solve? 3 by 3s, yes. 4 by 4s, no. 3 by 3s, yes. 4 by 4s, no. I'm going to answer Kathleen's as I else as far as finding determinants. Go ahead, Kathleen. What's up, kid? Uh-huh. The plus or minus? It's the definition of cofactors and how cofactors, I need to alternate the signs as far as the placement in the matrix. Yeah, but if you choose another row, then you're going to be doing different numbers. So if I was to choose, I would have put opposite, same, opposite entries. Does that make sense? I took my matrix, I added a couple more columns, and I'm going to main. 0 times anything is 0, plus main, 2 times 2 is 4 times 4 is 16, plus main, which is opposite, minus opposite, which is negative 4, plus opposite, which is 0, plus opposite, which is 6. I have 16 minus 2. But it only works, this trick only works. Bye, cool kids. I'll see you later. Both find determinants. This is trick on the right, main minus opposite, only works for 3s. I take the first two. Well, however many I need to, well, it only does 3 by 3s, so you have to copy the first two. Do you want just this one, Kim, or do you want the one before too? Just that one? My poor door. Be nice.